Welcome everyone, I'm Filippo Balzano from the University of Bologna, and what we will see together is one of our last research. So let me move quickly to the structure of our presentation. That we'll see a brief introduction on the themes of our work. Then I will move on the materials and the methodologies used in this research before finally moving to the main results and to conclusions. Our work is focused on microsurfacing, and as you may know, microsurfacing is mainly a preventive treatment that consists in a thin layered mixture composed of aggregates, water-based modified bitumen emulsion, chemical fillers, and mixing water. And why are many companies turning in the direction of microsurfacing? Well, because it's a very effective way to, in general, extend the life of our pavements by resealing the minor cracking, and so restoring the waterproofing of the bottom layer, and also, of course, increasing the skid resistance of the top layer, involving way less material, way less energy, way less emissions, and in other words, way less money than reconstruction. But we need to keep in mind that we are talking of a thin layer, so our mixture needs to be strong, and also we need to ensure a long-lasting bonding with the support. And nowadays we have a lot of tests of guidelines to assess the mechanical properties of the microsurfacing, but nothing unified to evaluate the bonding level for these compounds. And that's the starting point of our project, where we had a preliminary phase where we collected a large number of real existing pavement combination, including very different layers, so very different aggregates, porous asphalt, dense asphalt, also some non-bituminous binder. And we wanted to focus on very different textured pavements. And why we wanted to focus on texture? Because texture can affect the bonding with the new layer by means of the mechanical interlocking between the particles inside the macro texture of the support, and also by means of the mechanical and chemical addition related to the micro texture of the aggregates. So we wanted to suggest, first of all, an easy way to assess the texture of our support in lab. As you can see in this slide, this is an adapted version of the sand patch test, nothing new. And again, a very standard British pendulum test that is a very simple way to assess the friction of our support. But on the other side of the coin, we also wanted to include an advanced approach for the texture evaluation involving a close-range photogrammetry technique, which aims to read the texture starting from a large number of pictures taken from different angles and merging together by creating a high-definition 3D model. As you can see, this one is not a video, this one is a 3D reconstruction of our texture obtained by using a software. And from the 3D models, we were able to collect a lot of texture information, as for example the Abbott curve, which is something very reliable. And once we had all our support described in terms of texture, we moved to the microsurfacing application. So we took from the market a high-performance mixture, and we applied it, the mixture on the samples in the same way. And finally, we tested our double-layered sample using an adapted version of the direct shear test with the Leutner apparatus. And before moving to the results of the direct shear test, let me take a few seconds again to talk about texture, because as you may know, when you involve texture, you can find hundreds of parameters, of indicators, depending on what you need. So we decided to select a short list of parameters, including both volume parameters from the Abbott curve, height parameters, and also some shape parameters like the kurtosis. And I want to remark that all this list can be obtained just using the advanced approach. So before moving on, we wanted to compare the standard approach with this photogrammetry analysis, and we find a lot of huge correlation if you compare the similar indicators. And this maybe look trivial, but it's not, if you consider how different the two approaches are. And in the same way, when you analyze direct shear curve, you can read a lot of information. You can obtain load, stress, displacement, modulus, energies. And we found a lot of interesting tendency by comparing these quantities with the texture. By way of example, I'm showing here how the resistance modulus of Goodman increase by increasing the macro texture of the sample. And you also can see how payments sharing the same texture family show a similar behavior to direct shear. And let me remember that the only property this payments share is the texture. When you see a different color, that stands for very different aggregates, different density, different binder. And so we can conclude how the same microsurfacing mixture can have a very different behavior by relating of the variability of the support, and also how a deeper knowledge of the support can guide the mix design. And in the end, we also showed how to adapt a normal standard Leutner shear test and use it on these special compounds. Thank you for your attention.